Hello, today we are looking at 13.2 general angles, and this is the first day of 13.2 where we're going to concentrate our efforts on degrees. And we're going to start by drawing angles. You can generate any angle by fixing one ray, called the initial side, and rotating that around the other ray, called the terminal side. About the vertex. So when we look at our standard grid, we know that starting point is at 0. If I go straight up, this is 90 degrees. This is 180 degrees. If I go from 0 to 90, that's plus 90, plus 90. Each of these are 90-degree increments. So this has to be 270. 180 plus 90 gives us 270. And then we finish all the way around. 0 is also 360 degrees. The vertex is always going to be at the origin. Alright, so when we have angles in standard form, the initial side would be starting at 0. So this would be the initial side of our angle. And wherever we decide that angle to stop, so if I go here, travel all the way around, and if I stop here, wherever I stop is going to be the terminal side. And again, your vertex is always going to be there at the origin. Let's go ahead and graph a couple in standard form. Until things get a little bit easier, let's just remember that we label 0, 90, 180, 270. And we want to measure or draw an angle that's 200 degrees. So we start at 0, we go to 90, we go to 180. I have to go past 180 just a little bit, not enough to go here because that's 270. So that's how I would draw my angle of 200 degrees. And yes, you must show me this rotation. So you show me that you started at 0 and you rotated around until you got to the 200 degree mark. Negative 100. So we know that we have 0, 90, 180, 270. But if I'm going a negative 100 degrees, then I have to go the opposite direction. So instead of going around our circle this way, we have to go the other way. So if I look at this, this means that this is really a negative 90 degrees. This would be a negative 180 degrees, and this would be negative 270. This would be a negative 360 degrees. I want to go a negative 100. So we still start at 0, our side, our initial side. I go the opposite direction. I go past negative 90 slightly till I get to a negative 100 degrees. Our vertex is still coming from that origin. So if we are going with a positive angle measure, we are going counterclockwise. If we have a negative angle measure, we are going clockwise. Well, what about something that's 600 degrees? We know we've got 0, we've got 90, we've got 180, we've got 270, we've got 360. 600 doesn't really fit anywhere on there, so we've got to figure out what to do. I'm just going to keep on going around my circle. 360 plus 90 gives us 450. 450 plus 90 gives us 540. 540 plus 90 gives us 630, which is enough. So again, we start at our terminal, or our initial side. When we go all the way around once, we've gone 360 degrees. Once I get here, I've gone 450, 540. I want to go past 540, 630. I want it to be generally accurate. So if I were to go halfway, that would be 45 degrees, so I'd be at 585. So I know that I have to go more than halfway around there, and I would be ending about there. And that would be about a 600 degree angle. This is why it's important. This is why I said you have to show those marks going around your circle. That indicates how many times around it has gone. So you want to always start at the initial side, indicate your arrow, so indicate which way you went. This one I went this way. That will tell me whether your angle was positive or negative, and the spinning actually tells me how many times around the circle you have gone. So as a reminder, if the angle measure is positive, the rotation is counterclockwise. If the angle measure is negative, then the rotation is clockwise. Not too bad. Next, we're moving on to finding coterminal angles. So we talked about terminal sides, so that's where an angle is going to stop. Coterminal. Two angles are coterminal if their terminal sides coincide. So if those two angles stop at the exact same point. An angle coterminal with a given angle can be found by adding or subtracting multiples of 360. So for example, I have 205 degrees that was already graphed for me. We start at 0, we have 90, 180, 270. I want a coterminal angle, one that is positive and one that is negative. If I started at 0 and I stopped there at 205 degrees, that was the given angle. Now I want to find a positive coterminal. A positive coterminal says, okay, I get to 205, I'm going to keep going. Now I'm going to end right back up there, but I went one more time around the circle. One full rotation around the circle means I had to add 360 degrees because we know that there's 360 degrees and one full rotation around a circle. So to find the angle measure, we take the angle that we were given, 205, and we add 360 degrees. That gives me 565 degrees. That is only one example of a coterminal. I have an infinite number of positive and an infinite number of negative coterminals because I can just keep on adding 360, add 360, add 360, and it will forever keep going around my circle, around and around and around. Now I need a negative coterminal. So again, we still are starting at that 0 mark. If I'm going a negative angle, I'm going the other direction. That means that this would be a negative 90, this would be a negative 180, a negative 270. You may think that this one's a little bit harder to find, but it's really not. We just take that 205, instead of adding 360, we subtract 360, and we see that we're at a negative 155 degrees. And you see that this was negative 90. It's in between negative 90 and a negative 180, and we're right there. Remember, you got to show those rotations, which arrows we're going, which direction we're going. We could, again, subtract 360, subtract 360, keep on going, and getting an infinite number of coterminal angles. Don't forget, a coterminal angle is just another angle that's one more rotation about the vertex, which is your center. I can keep going, keep going, keep going, so there's an infinite number of coterminal angles that I could have. Okay, let's go ahead and flip on over to the back side. We want to list one positive and one negative coterminal angle. But we also want to actually graph our 150. So we start at 0, 90, 180, 270. We always label, just like any other graph, we always label those angle measures. If I'm starting at 0, I go to 90. I don't want to go all the way to 180. You do have to think about how far do I have to go. If you drew your 150 angle right there, it would be marked wrong. So you have to think about where is 150 located. Is it closer to 90, closer to 80? How closer to 180? How much closer? Where is it about? So if I go halfway, I'm at 135. So I'm going to go about 15 more degrees. So my angle is going to end about right there. It doesn't have to be exact, but it does have to be accurate. So if I want a positive coterminal angle, instead of going and stopping, I'm going to go and I'm going to continue back around one more time. And to get there, we have to take that 150 and add 360 degrees, where we get 510 degrees. Now we want a negative coterminal. So we still start at 0, but instead of going and continuing around, we go the other direction. So I'm going to find that angle measure from 0 going clockwise. So we take 150 minus 360. It's always either adding or subtracting 360, depending on if you want a positive or negative coterminal angle. And we have negative 210. Again, this would be negative 90, negative 180, negative 270. You see that it does fit there. It's more than a negative 180, but less than negative 270, and it's closer to that negative 180. Okay, so we get to our next one, 400 degrees. This one's a little bit different. We always start by just graphing that actual angle. Our 90, 180, 270, 360. It doesn't fit again. So we start at 0. We go all the way around. We're at 360, but that wasn't enough. We need to go 40 more degrees. So just slightly less than halfway. It's not a very good straight line. Go ahead and fix that. Okay, so there is our angle measure of 400 degrees. We want a positive coterminal and we want a negative coterminal. Now there's a couple different ways that we can find this positive coterminal. Just like before, we can start or pick up where we left off at 400 and go one more time around. And that gives us, I don't know why I want to say 300, 400 plus 360, and we get 760 degrees. Now when we go to find that negative coterminal angle, we know that it's from 0 going the other direction. However, when we do this, we do 400 minus 360 degrees, and when we do that, we're left with a positive angle, and we know that it's going to be a negative angle. The reason for that is if I go from here, from the original ending point, and I go 360 degrees around, I haven't gotten to the negative angle measure yet. So I need to go more than 1. So when I take that and I get to that 360, I gotta keep going again, and then this part right here is showing that a negative angle measure. So I have to take that 40, go in the negative rotation one more time to get that negative 320 degrees. And again, if we start here, that's negative 90, negative 180, negative 270, and we see that we do end up at a negative 320 degrees. It just took us 2 rotations to get there. So normally you only have to add once and subtract once. With our adding and subtracting, we found 2 positive coterminals and 1 negative. Don't forget that it can go infinite in both directions. On a quiz or test, generally we take the closest one. I will accept 760 or 400. Negative 320 is also an option for your negative. You can go one more if you want to. Generally people don't because you just have to do more work. Alright, so let's go ahead and I want you to press pause and try to do negative 310 degrees on your own. Alright, let's see how you did. We start at 0 because we have a negative angle. We are going to go clockwise, so we see in blue. We went all the way around to negative 310. For our positive coterminal angle, from there, if we want positive, we have to go counterclockwise. So I go 1 rotation all the way around that 360 degrees from negative 310. So I add that 360 and I get 50 degrees. This is the part from the initial side to the actual terminus side. That is that 50 degree angle mark. So even though I started here, because I had to do that full 360 rotation, the only angle that's being measured is from the initial side to the terminal side. With our negative coterminal, it was already negative. So I started there, I went all the way around, that's where negative 310 was. That angle was the angle we were given, so we have to go around one more time, subtracting 360, going clockwise to get negative 670. Alright, one more thing left. And let's think about geometry. I know you're very, very excited. What is the circumference of a circle? If you say pi r squared, I'm not going to be very happy. It is 2 pi r. So that is the distance around an entire circle. So if we look at a circle on our coordinate plane, from start to finish, we have 2 times pi times r. So let's imagine that our radius is 1. So from here to here is just 1 unit. So we can say that 360 degrees is equal to 2 pi. So 360 degrees is the same thing as 2 pi. And 2 pi is going to be the distance around a circle in radians. And we're not going to talk about radians today, so don't freak out. Don't think we're going to have another 20-minute video, hopefully. We are just going to touch on radians very, very quick. And we're going to talk about how to convert between degrees and radians. If I want to go from degrees to radians, I multiply by pi over 180. If I want to go from radians to degrees, I multiply by 180 over pi. So the same thing, just the reciprocals. So if I want to convert 140 degrees to radians, so I want to go from degrees to radians, I'm going to use this first conversion. So I have 140 degrees. I'm going to multiply that by pi over 180. Our first piece wasn't a fraction. I could put it as a fraction by putting it over 1. 140 times pi divided by 180. So we are going to reduce 140 and 180. That's going to reduce down to 7/9. So that just becomes 7 pi over 9. Pi over 8, we want to convert that to degrees. So we've got pi over 8. Since I'm going from radians to degrees, I'm going to multiply by 180 over pi. Now we know that anything divided by itself cancels. So the pi's cancel. I just reduce 180 divided by 8, and we get 22.5 degrees. This is where it becomes crucial to make sure that you are labeling your degree marker. Now we have angles in radians and angles into degrees, so this little marker is the only thing telling me that you have degree mode. I think this is relatively easy if you just think about it for a second. If I have radians, I have pi in my answer. If I have degrees, there's no pi. So if I want pi, pi is on top. If I don't want pi, pi is on the bottom. It's the same fraction though. So if I want to go from degrees, which we're given 500, to radians, I want radians, so I want pi, so pi is on top. We reduce 500 over 180, and we get 25 pi over 9. Good, done. I have radians, which means I want to get rid of that pi. The only way to get rid of that pi is to have them cancel out. So pi goes on the bottom, those cancel. Now there's a little bit difficult than the first one. It's 45 times 180. Then we divide by 3 to get 2,700 degrees. Alright, there's only 2 more left. I want you to press pause and do the conversions yourself. Alright, let's see how you did. The first one, we are converting to radians, so we want pi on top. When we reduce our fraction, we have a negative 5 pi over 9. With our last one, we have radians. We want to get rid of that pi, so we have degrees left, so those pi's cancel. We multiply a negative 39 times 180 divided by 6, and we get a negative 1,170 degrees. It's only a minute shy of 20, but at least it's under 20, and we are all done.